Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss about the different types of digital to analog converter and analog to digital converters using op amps, analog to digital signal conversion, as well as digital to analog signal conversions using operational amplifiers, particularly IC741 IC. To introduce about these kind of converters, interface the digital and the analog world. We need converters that can convert analog to digital, and digital to analog, isn't it? So we are in need of analog to digital converters. The converters which convert analog signal to digital signals are called analog to digital converters. In short, we call them as ADCs. And the second type of converters, digital to analog converters. The converters which convert digital signals to analog signals are called digital to analog converters, and in short, we call them as DAC DAC. Analog signals are those signals in which the physical quantities are continuous, infinite number of quantities over a given range of values. Examples for analog signals are temperature, pressure, time, velocity, acceleration, fluid flow, etc. And digital signals. What are digital signals? Digital signals are those with discrete values and are represented by binary codes, that is, in the form of zeros and ones. Examples are digital audio, system signals, electronic music systems, etc. Yes, so when we are trying to convert these analog digital signals, in turn, we need an interfacing between the main system and the converter system, isn't it? So, interfacing is a process of making two or more devices or systems operationally compatible with each other so that they function together as required. That is interfacing the analog into the digital world. I draw a simple block diagram of interfacing circuit. So if this is an interfacing circuit, the analog world continuous values in a given range. Yes, is fed to the interface circuit, and the output of the interface circuit is fed to digital world, discrete set of values. Yes. So in this case, the analog components are sent to an interfacing circuit, and the output of the interface circuit is sent to digital world discrete set of values. So these have analog signals like this with continuous values, and the digital world signals have discrete set of values in the forms of zeros and ones. So if this kind of conversion is happening, that is analog to the interfacing circuit and then to the digital world circuit, then this kind of conversion is called analog to digital conversion. While the digital world discrete set of values of zeros and ones are fed to the interface circuit, and the output of the interface circuit is fed to the analog world signals, then this kind of conversion is called digital to analog conversion. So both ways we need an interfacing circuit to convert analog signal to digital signal or from digital signals to analog signal. So where are we going in for these kind of interfacing? The real world interfacings, like for examples, electronic thermostat, CD player, digital audio tape players, recorders. All these are real world interfacing. Yes, a digital signal may be of this kind. For example, one example. What I've shown is an example of a digital in terms of 0, 1, for example. All these are in terms of zeros and ones. This is possible to be converted into its proportional analog signal. Yes. So this is the analog signal with continuous values, and these are digital signals. So a real world interfacing circuit needs these kind of conversions. So digital to analog is carried out, as well as analog signal of this variety is carried out. Hence, we can call them as a bidirectional conversion. So what are the different types of digital to analog conversions? Many types are available. Usually, we include switches, the kind of active element, resistors, op-amps are used to implement these kind of conversions. Then we'll be discussing about the main two types of digital to analog converters. They are binary weighted resistors and R to 2R ladder type of digital to analog converters. So what are these digital to analog converters? For example, the digital signal, as we know, they will be fed in terms of zeros and ones. These are the digital inputs. A, B, C, D. So four inputs are there. We call this as 4-bit. So the name of the DAC will be 4-bit digital to analog converter. And the output of this DAC will be the form of V0. Yes, across which we will be getting the output. This will be in the form of analog signal. So a digital signal in the form of zeros and ones are converted to analog signal. For example, 48 volts, 48.001 volt. Example can be obtained the output of a digital to analog converter. If K is equal to 0.5 and DCBA, for example, DCBA is equal to 101, then the value of the analog output V0 formula is the value of the digital input into K. K is the constant, and what is the value? is going to be 1011. The equivalent for 1011 is 11 in terms of decimals. 11 into 0.5 is 5.5 volts. So a 1011 input is given and the factor for conversion is 0.5. 0.5 is a conversion factor. Then the output will be 5.5 volts in the form of analog. So thereby a digital 4-bit data has been converted into its equivalent analog data. The resolution and full scale value voltage. The resolution or the step size of a DAC is the smallest change that can occur in the analog output as a result of a step change in the digital input. So it depends on the least significant bit weightage. The analog output, as discussed now, is equal to the value of the digital input into K. K is the analog output or digital input resolution or the step size. The full scale output is the DAC output when digital input is at maximum value. So for example, another 4-bit data, if it is 1112, okay, 111's equivalent decimal value is 15, then it is 15K. For n-bit DAC, the full scale output is equal to full scale output is equal to 2 power n minus 1 to k. Example, if the step size k of a 10-bit DAC is 0.0005 volts, then the full scale value voltage value is, this can be converted directly accordingly. The full scale voltage. The full scale voltage, in short, we call it as FSV. Full scale voltage is the output voltage of the DAC when maximum value of the digital inputs are applied. So here, for example, if we take a 3-bit counter, a digital circuit counter counts the values of the digital circuit when a clock pulse is given. On the trigger of this clock pulse for a particular time TC, the output of the 3-bit counter A, B, C values, let this be A, B, C values are fed to a 3-bit DAC. So a counter circuit is a digital circuit which will give a 3-bit output, for example 001, and the output of this is obtained like this, V out. The full scale output is 7 volts. Then the resolution is equal to 1 divided by 2 power 3 minus 1 into 7, which is equal to 1 volt is the output. Yes, another for the given example. What is the step size for a 4-bit DAC operating with the full scale value voltage of 8 volts? Yes, so that value for a 4-bit DAC operating with the full scale voltage of 8 volts, then it is 8 divided by 2 power 4 minus 1. So which is 2 power 4, 16, 16 minus 1 is 15. So the value of the output voltage is 0.53 volts. So we can calculate the exact resolution of the output voltage also. Next parameter is percentage regulation. Although resolution can be expressed as the amount of output voltage near per step, it is useful to express it as a percentage of the full scale output. That is, percentage resolution is equal to step size divided by full scale value into 100%, which is equal to k divided by 2 power n minus 1 into k